Get rid of your old computers, because the future of technology has arrived. It's not artificial intelligence or virtual reality. It's something called quantum computing. And it could completely revolutionize every aspect of our society, from healthcare to finance and even national security. But what is it? And how does it work? When can we expect it? And what could happen if it gets into the wrong hands? This is What If, and here's what would happen if we had working quantum computers today. Basically, a quantum computer is a super efficient version of the regular computers you already know and love. When a regular computer is used to solve a problem, it has to filter through all the possible answers one at a time. Whereas a quantum computer can filter through 1 billion possible answers at once to find the correct one in just a fraction of a second. The technology is so advanced that hardly anyone knows how to program it, let alone how to use it. So, how much power and control would quantum computing give to the first country or person who perfects it? Alright, to understand how quantum computers are going to change your life, it helps to understand how they would work first. Today, computers are binary. They process information using bits, where every bit can only exist as a 1 or a 0, and nothing else. A bit is relatively simple. It's the representation of one state or another, like if a light bulb is on or off. In today's computers, a bit is represented by a current pulse or an electrical voltage. Are you still with me? Alright, we're almost there. In the case of quantum computers, information is processed using qubits. These are similar to bits, but they can be ones and zeros at the same time. To understand the difference between bits and qubits, picture a sphere and give it both a north and south pole, where the north pole represents 1 and the south pole represents 0. With a bit, the poles are the only usable spaces on the entire sphere, and only one of them can be used at a time. With a qubit, the whole sphere becomes a usable territory. You don't have to grasp the complicated physics behind it, but the main point to take away is that qubits can deliver more complex data and allow us to encode more information into much smaller computers. Some of the most progressive tech companies like Google, NASA, and IBM have already made versions of this technology. Now they're racing to perfect it. Once they're perfected, quantum computers will offer lots of benefits. For one thing, they'd be a game changer in the field of cryptography, mainly because of their ability to enhance security protocols by generating truly random numbers. Because of this protection, communications devices that are quantum-based could be used to transmit medical and government records, defense data, or other sensitive materials without fear of them ending up in front of the wrong eyes. Being able to calculate and process so much information so much faster would help us to find new drugs to treat diseases. It would speed up the development of life-changing medications. Quantum computers would give us the power to better deal with climate change by allowing for better software models describing what is happening to our atmosphere. And that could help us reverse the adverse effects of climate change. But it's not all good news. As we said before, no one's perfected it yet. If the first person who does wants to use the tech for ulterior motives, we could all be in trouble. As soon as a working quantum computer exists, our modern cybersecurity methods would become almost useless. Today's encryption algorithms use huge math equations and problems that are virtually impossible to solve. A quantum computer, with its 0 and 1 dualities, would have the power to solve these algorithms with relative ease. So I guess we'll just have to cross our fingers that one of the good guys figures it out first. Maybe we could even use these early generation quantum machines to perfect future models and make them even more powerful.